Okay, question 20, and is the number of points of intersection of the graphs y equals x squared minus a squared and y equals a squared times x minus 1, where a is a real number. What is the smallest value of n? That's not possible. Okay, so we're gonna try different values of a essentially, right, and then see how the graphs interact really. Yeah. Okay, so first observation is that no matter if a is positive or negative, it yields the same results. Yeah, because all of these involve a squared. Yeah, so the positiveness and the negativeness of a doesn't matter. So let's just think if a is positive. Okay. All right, or non-negative, say, because a can be 0 in some way. Yeah. Okay, so what happens when a is 0? If a is 0, then y equals to x squared and y equals to 0. Well, then how many intersections have you got? Well, 1, right? I don't need to draw this graph. It's trivial. You have x squared and y equals 0. It's just axis. Yeah. So n equals to 1 is possible. So a is already wrong. Okay, but then let's think of if a is slightly bigger. All right. Let's say a is between 0 and 1. Let's start with that. All right. So I'm just going to keep on increasing the value of a. Okay. So how does that look like? So first of all, I'm going to draw a diagram here. So x squared minus a squared is a quadratic, which so imagine a quadratic going down here, right? And if you take the absolute value signs, you get reflected here. Okay. All right. And you have a squared is x minus 1, right? So you have 1 is here basically. So this is a V shape, right? Because it's an absolute value graph, so it's a V shape. So the bottom of the V is at 1. Yeah, remember I'm assuming that a is between 0 and 1 now. So a squared is less than 1. Okay, so what points must it pass through? Well, remember it must pass through this point, the V. Right? The V must pass through this point. Because when x is 0, then both graphs yield y equals to a squared. Yeah, the y-intercept of both graphs is a squared. So therefore, I know that it passes through these 2 points. So I probably have a line which does this. Okay, and I'll have a reflection here because it's an absolute value graph. So already you can see I have 4 solutions. All right, so 4 is possible. So D is wrong. Happy so far? Okay, now we're going to look at when A is 1. Bang on 1. Okay, so again, I probably need a new diagram here. All right, so let me get rid of this. Oh, well, I could keep it quadratic, right? I could just assume that the 1 is at the new place. Okay, so I'm going to be here. All right. Okay, so the 1 is at a squared. This equals to 1. Okay, so how does the V look like? Well, again, I got to pass through this point, right? I got to pass through this point. So this will look like something like this, and then up here. Right? Okay, so how many solutions have I got? Well, I've only got 3 then, right? If you count 1, 2, and then 3 here. Yeah, and I'm sure that the V actually doesn't hit it up here. Yeah, because you know that the quadratic grows quicker, well, much quicker, than the linear function. Yeah, so they're not going to intersect afterwards. So therefore, n equals to 3 is possible. So C is also wrong. Okay, how about when a gets even bigger than 1? What happens when a is even bigger than 1? Okay, so now, again, I'm just going to change the position of my 1. Okay, I'm going to keep the quadratic and I'm going to change where the V is. I think that's the most convenient. Okay, so therefore, my 1 is somewhere here now, right? Because a squared is greater than 1, of course. If a is greater than 1, a squared is greater than 1. Okay, so my V, remember, I have to pass through the point here. The y-intercept is always the same. Then I would have something like this. I mean, if you pass through y-intercepts. Okay, that's really poor drawing, but you get the idea, all right? So it should be a reflection like this. So again, I have 4 solutions, right? I hit 4 times if you count. So again, n equals to 4 is possible, right? Okay, so I've considered all the situations for A. I've exhausted all the situations for A, right? So therefore, n equals to 2 doesn't seem possible at all. So therefore, the answer would be B.